equation H2O2 yields O2 plus H2O, we'll first count up the atoms on each side of the equation. On the reactant side, hydrogen, we have 2, and oxygen, we also have 2. Over here on the product side, hydrogen, we have 2 of those, and then oxygen, we have 2 right here, but we also have to count this. So if there's nothing written, it means there's a 1 there. That's implied. So we have the 2 plus the 1, and that gives us 3 oxygens on the product side. So the hydrogens, we have 2 on each side. Those are balanced. The oxygens, we have a 3, and then we have that 2 there on the reactants. So what we can do, whenever I have an odd number, I like to get that odd number of oxygens to an even number. And I can do that by multiplying it by 2. So let's put a 2 in front of the H2O and see how that changes the oxygens. So we've put a 2 in front of the H2O. That means we've also changed the hydrogen. So 2 times 2 here, that equals 4. So we have 4 hydrogens, but we can deal with that. And then oxygens, we have the 2 here, plus now we have 2 times the 1, 2 oxygens, which gives us 4 oxygens. So now we have an even number that's going to help us out. Let's go back to the reactant side. We have 2 hydrogens and 2 oxygens, and we want both of those to be 4. If we put a 2 in front of the H2O2, we'll have 2 times the 2 here. That equals 4, so the hydrogens are balanced. And then 2 times the 2 oxygens, that also equals 4. So at this point, all of the atoms on both sides of the equations are the same. We're obeying the law of conservation of mass. In this equation, it's balanced. The thing that catches people on this problem, this particular chemical equation, is we have the 2 oxygens here, but then they forget about the 1 oxygen here. So we need to add all these oxygens up on the product side in order to solve this chemical equation. Also remember that if you have an odd number of oxygens, sometimes multiplying it by 2 will make the chemical equation much easier to balance.